Now let's say about law of radioactivity. First of all, what is radioactivity? A nucleus called parent nucleus is converted into other type of nucleus, and that what we call daughter nucleus. So if a nucleus convert into other nucleus and which is having different physical and different chemical properties, once this radioactivity starts, we can't stop that and we can't control it or suppress that type of action, and you can use a physical or chemical actions. We can't control that is a spontaneous process. And here disintegration or rate of disintegration, nothing but what is disintegration? Within 1 second, how many nucleus of parent atom are converting into daughter atom, that what you call rate of disintegration. Within 1 second, how many are converting? That is directly proportional to number of nuclei present in the parent atom. At that instant, how many nuclei are present? More number is there and more number of nuclei are disintegrated. Less number, less. So directly proportional. The rate of disintegration is directly proportional to number of nuclei present there. That is a parent atom present there. Suppose you can assume some number of nuclei are there initially. After some time, and what is a number of nuclei disintegrated? Disintegrated means which are converting from parent nuclei converted into daughter nuclei within a time gap, a small delta t. So what is dn by dt? Number of nuclei break or disintegrate, or we can say decay, from parent to daughter nucleus. That is directly proportional to number of nuclei present there. More number of nuclei available and fast disintegration is there. That is, number of nuclei break is more, decay is more. To remove this proportionality, they use a constant, a lambda. This what you call proportionality constant here, that is disintegration constant. Disintegration constant, and here negative sign represent, this is the initial number of nuclei present. Now what happened when some number of nuclei converted from parent to daughter nuclei? This number decreases. So this negative sign shows decrease in the number of parent nuclei. That lambda is disintegration constant. See that lambda is called a disintegration constant. Negative sign indicates a decrease in parent nuclei. Suppose if you assume initially at t equal to 0, number of nuclei present in the parent nucleus are n naught. N is equal to n naught. Suppose after time t, suppose you can take after a time t, that number going to change as n. Initially t is equal to 0, that is n naught. After a time, that number is n, you can think. Then according to law of radioactivity, so dn by dt is equal to minus lambda n. So you can send this n the side and dt this side. So dn by n is equal to minus lambda dt. Take integration both sides. Integration dn by n, and that side minus lambda is outside, integral dt. Time changes from 0 to t. Time changes from 0 to t. And what is the number of nuclei changes? Initial number is n naught and final number is n. So number of nuclei changes from n naught to n, and within what time? T to 0 to t. And apply integration. And you see this is just like a 1 by x dx now. So what is the integration formula for integral 1 by x dx is equal to log ln, means natural logarithm ln x. So ln or log base e, both are same. So you get ln x. That you can write here. Integral 1 by n dn is log n, limits n naught to n. And other side, integral dt is t and limits 0 to t, we can write here. And substitute these limits. Here first put upper limit minus put lower limit. Log n minus log n naught is equal to minus lambda t. Even you substitute that t minus 0, you get t. And this we can note as equation 2. Further we can use this to explain about graph, and here equation 2 you can write. And now this you see log x minus log y. Log x minus log y you can write as log x by y. Suppose plus c is there, what you get? Log x into y you can write. Here log n minus log n naught we can write as log n by n naught is equal to minus lambda t. To remove logarithm this side and apply exponential this side. So if suppose we can take log x equal to y, if you want to remove logarithm here, and here this side it become e power y, x equal to e power y. Similarly here log n by n naught and is equal to minus lambda t become e power minus lambda t, and this become n by n naught, and send n naught that side. So n is equal to number of nuclei present after some time. Means you can say number of nuclei remains there. Why? Because some of the nuclei are converted into daughter nucleus, disintegrate into daughter nucleus, and remaining number is n is equal to n naught into e power minus lambda t. Suppose how many number of nuclei disintegrated, this is the remaining, and how many disintegrated? Initial n naught number of nuclei should be are there, and now how many are there? Only n number are there, so minus n. So n minus n value, no, n naught into e power minus lambda t, that you can substitute here. Take n naught common. Number of nuclei disintegrated, already destroyed, or which are converted from parent nuclei to daughter nuclei is n naught into 1 power 1 minus e power minus lambda t. We get this number of nuclei left undecayed. Still parent nuclei how many are present? This how many daughter nuclei are present, means the number of nuclei decayed, and number of nuclei decayed here. Suppose if you draw graphs for these two cases, so for first graph you see when time is increasing, what happen? When e power negative value increases, then this total value decreases, when t equal to infinite, then only it become here 0. Why? Because e power 1 by infinite, then it become 0. And here what happen, you see, for long time, even after infinite time also, that means for at infinite only it becomes 0. So initially the number of nuclei present is n naught, and gradually what happen, initially the number of nuclei decreases very fast, but after some time what happen, it becomes slows down, and even infinite time is there, this number of nuclei won't become 0. Some parent nuclei is present even after a long time also. This is exponential curve using that equation. Similarly, how many number of nuclei converted from parent to daughter nucleus, or you can say number of nuclei disintegrated. That initially fast increase is there, but after long time what happen, and it won't reach maximum value. So here initial number n, that completely to convert into daughter nucleus, it take infinite time, very long time it take. That's why it never able to reach the maximum value. All nuclei are not able to convert. Now you see an averagely how much time each nuclei is survived. For example, initial number is n naught is there, and when process radioactivity start, immediately with the 0 time only some nucleus are break into other nucleus, and parent convert into daughter nucleus. But in some cases, even after long time is there, infinite time is there, some nucleus are survival there. So on averagely, what is the probability of survival of a nucleus? That is, probability of survival of nucleus is n is the number of nucleus remaining, and n naught is the number of nucleus present initially. So from that equation, send that n naught this side, n by n naught is the probability of nucleus survival is this. And how many nuclei are disintegrated? The probability of disintegration. So this is the probability of survival, means 1 minus the probability of survival gives probability of disintegration. If you take a nucleus in the material, and how much time it take, or at t seconds how many number of nuclei break, whether this nuclei breaks or not, that will be gives the probability of decay is 1 minus p probability of survival, that is 1 minus e power minus lambda t. Now we'll see about suppose if you draw a graph between, there we discuss about a graph between number of nuclei remaining and time, and number of nuclei disintegrated and time. Those are exponential curves we get, two curves. Suppose if you take log of number of nuclei remains. Suppose for example their equation 2 is there, that is log n minus log n naught is equal to minus lambda t is there, and send this log n naught this side, and log n is equal to minus lambda t plus log n naught. This you see, this is like c constant, and you see t is like x, and log n like y is equal to mx plus c. You can compare this equation, and if you draw a graph like and y log n on x time, and minus lambda is the slope of the line. So this equation represents a straight line which is having negative slope. That's why you get a line like this. Initially log n become log n naught. Why? Because t is equal to 0, what do you get? If t equal to 0, log n is equal to log n naught. So log n become log n naught. When time increases, what happen? And this value decreases, minus something is there, decreases, but it represents a straight line because slope is negative, and this is compared with y equal to mx plus c. So you get like this. Suppose if you take a sample, initially number of nuclei present is n1. After some time it changes to n2. Then how much time it take to change from n1 number of nuclei to n2 number of nuclei? Parent nuclei initially n1 present, some are disintegrated, and now we have only n2 number of nuclei. Then what is the number of nuclei present? What is the time taken for that? For that we have one equation, log n by n naught is equal to minus lambda t. So using this, send this minus lambda that side. Then what do you get? T is equal to minus 1 by lambda log n by n naught we get from this. T is equal to minus 1 by lambda log n by n naught we get. And to remove this negative sign, reverse this log value, that is log n naught by n you can write. So time t is equal to 1 by lambda log n naught by n. This negative sign here, log reverse, no? So negative sign gone. This is the time taken to disintegrate initial number of nuclei present n naught. Now only n is there. So how much time it will take to disintegrate a number of nucleus n naught to n? Similarly here what they mention, initial number of nuclei is n1. Now it is only n2. What is the time taken? 1 by lambda log n1 by n2. Sometimes they ask about initially mass of the radioactive substance is m1. Now after some time it is m2. What is the time taken? T is equal to 1 by lambda, similar formula, 1 by lambda log initial by final mass. Sometimes they give that initially some fraction of nuclei is there. Suppose for example somewhere it starts and now 1 by 2 elements are there. After some time it becomes 1 by 8 of nuclei number. Initially half of the nuclei number is there. Now we have only 1 by 8 of nuclei. So if they give fractions, how to solve? Initial fraction of nuclei present in the sample is f1. Now it is f2. So how much time it take to fall number of nuclei, fraction of nuclei fall from f1 to f2? We can use similar formula. Suppose activity. So activity means within 1 second how many nuclei are break. And within 1 second how many nuclei are break? That is more when number of nuclei are more. So that means this is the activity initially, how many number of nuclei break for 1 second. This after some time how many nuclei break for 1 second. So how much time it take to fall, the activity of the material fall from A1 to A2. For this also similar formula, you see all are similar. Initial by final log of. So how much time it take, you can calculate. Suppose for some cases they give initially X percentage of material is there, X percent of nucleons are there, and now Y percent of nucleons are there. How much time it take to disintegrate from X percent to Y percent if they ask? Then we can use that log X percent by Y percent. T is equal to 1 by lambda log X percent by Y percent. All are same. Initial number of nuclei by final number of nuclei, initial mass by final mass, initial fraction of nucleus by final fraction of nucleus, initial activity by final activity, initial percentage of nuclei present by final percentage of nuclei present. Similar formula is there. There we mention activity. What is activity? Within 1 second, how many disintegrations or how many nucleons of parent nucleus convert into daughter nucleus? That is what you call activity. So activity nothing but we can write dN by dt, change in nucleons number by change in time. And this n value already we know. What is n? And using radioactivity formula, n is equal to n naught e power minus lambda t, we get equation. That we can write here, n naught e power minus lambda t. And n naught is constant, you can write outside. And lambda, why you get e power minus lambda t, differentiation is same only, we get e power minus lambda t. And again you have to differentiate this part. For that part, what you get? Minus lambda we get. So for e power minus lambda t, we get e power minus lambda t. Once you see that similar type of equation, we'll see that. For example, e power ax d by dx is there. This is the equation. And from this, what you get? E power ax, you get e power ax only. Again for ax, you have to do differentiation and multiply with that. That is ax differentiation is a with respect to x. So now what you get? A e power ax you get. In the similar manner, here what we have here, differentiation of n naught constant, e power minus lambda t. So for that e power minus lambda t, that only we get. And for this differentiation, minus lambda you have to write. Minus lambda. But activity means within 1 second how many number of disintegrated decreases, that only we are asking. That's why they didn't take here sign. So only you can think like a magnitude, you can think like magnitude. Then negative sign no need to take here. Then n lambda e power minus lambda t. This is what you call activity of the material. So activity. Suppose what is a relation? You see activity A is equal to n naught lambda, this equation only, e power minus lambda t. And what about this value? N naught into e power minus lambda t, that is n only now. So that we can write. Suppose you can take what is initial activity? Initial activity is n naught lambda is initial activity. When very beginning, if the number of nuclei is n naught, what is the number of nuclei disintegrated within 1 second? That is initial activity. So we can write A is equal to activity after any time is equal to initial activity, n naught lambda we can write as a naught e power minus lambda t we can write. This graph, this equation is quite similar to this. N is equal to n naught into e power minus lambda t. A is equal to a naught into e power minus lambda t. But this how number of nuclei are decreasing, and this how number of disintegration per second are changing. So initial more number is there, more activity. Now number of nuclei decreases, so now activity also decreases. The graph is same, only exponential graph we get. There how we are getting for n is equal to n naught into e power minus lambda t, how we are getting graph, similar graph here also we get. Activity also decreases. Suppose for example initial 1000 atoms are there. Out of 1000, 100 are break within 1 second. Now we have only 500. Now what happened? We get only 50 are nuclear break. Activity nothing but rate of disintegration is directly proportional to number of nuclei present. That only, and law of radioactivity. So this activity also decreases with time. To measure activity, we have some units, that is units of radioactivity, and 1 becquerel. BQ means becquerel. 1 decay per second. 1 nuclei is decayed within 1 second. That what you call 1 becquerel, and this is the SI unit. Based on scientist name Rutherford, 1 Rutherford is equal to 10 power 6 decays per second. Within 1 second, 10 power 6 nuclei are decayed. That what you call 1 Rutherford. Or 1 Curie, and biggest unit of radioactivity, that is 3.7 into 10 power 10 decays per second. That what you call 1 Curie. These are the units of radioactivity. Now about decay constant, that is about lambda. So we can define lambda also. It is a reciprocal of time taken to become atoms or nucleus decreases to 1 by e times of initial value, initial number. For example, you can see what is the number of nuclei after t seconds, e power minus lambda t. After how much time this number become 1 by e times? Suppose for example n is equal to n naught by e. After how much time the number of nuclei become 1 by e times of initial, that is equal to n naught into e power minus lambda t. So n naught get cancelled. E power minus 1 is equal to e power minus lambda t. What do you say? T is equal to 1 by lambda, no? T is equal to 1 by lambda. This only they define. After how much time the number of nuclei become e power minus 1, that is 1 by e times of initial, 1 by e times of initial number, that what you call decay constant. You see here how they define. It is a reciprocal of time during which the number of atoms decreases to 1 by e times of initial number, or atoms or nuclei you can take. If this value is 0, if disintegration constant is 0, that nucleus is very stable nucleus. Means that nuclei is not converting to any other nuclei. That is stable nucleus. If this value is larger, if lambda is big, then fastly within short time only those nucleus are converted into other nucleus. Parents nuclei are converted into daughter nucleus within a short time. That is about decay constant. 0 means stable and more means unstable. Unstable means fast, with high speed they can convert into other nuclei.